Hi everybody, Patrick here from EngineeringShock.com, ElectronicLessons.com, and PaintballProps.com. This product isn't ready for market yet, but I just wanted to show it off. In its preliminary state. I just got the PCBs in. What I've got here is a controller board. It is a wireless power transmittance controller board that allows for you to use external signals to control the onboard FET if you heat sinked, or you can use the onboard oscillator with adjustable with frequency adjustment and duty cycle adjustment to control the FET, to control a transmitter board. And the transmitter board is essentially a coil. There's some customization options on that board, but I don't use those for the transmitter, at least not yet, not in this configuration. The receiver board is exactly the same as the transmitter board. However, there are some passive components to rectify the received signal into DC, and there's also a 5-volt regulator in case you wanted to regulate down to 5 volts. Now, these specific boards aren't meant to handle a ton of current. These are for low power applications, but what you can do is, if you don't have these transmitter and receiver boards, you can attach your own coil to the output here. I'll show you in just a minute. So what I'm doing is I'm sending a mimicked AC signal to the transmitter coil, and it's just a coil of wire, a long coil of wire on a printed circuit board. And the receiver, which is matched, it's the exact same coil, is placed either close for more current draw or farther away for less current draw. And on the receiver I've got the option to just leave it as AC, to rectify it with a diode, a couple capacitors. There's a 5-volt option. You don't have to use a 5-volt regulator, but what I've got here is I've got a multimeter hooked up for short circuit current on the receiver board right here, and I'll give you a demonstration in just a second. And I've actually been able to achieve up to 90% efficiency at low power. At high power, what will happen is if you try to put a ton of power along this little coil, what's going to happen is you're going to damage the traces. So again, I'm going to be making some videos in the near future with some larger coils, but these specific coils are meant for low power applications. I wouldn't try to push past 200 or 300 milliamps across it. In any case, let's give a demonstration. The coils on the PCBs are windings of PCB trace many times around of the PCB. What I should have done to make it more efficient is rounded the edges, but I wanted to get the most out of this PCB, and plus it was experimental. I'm not used to using direct normal coils. The sides are in fact rounded, but not rounded as much as I'd like. I'd like it to be more circular, and that'll be in the next version, but this is working quite nicely. So in any case, what I'll do is I've got my multimeter here set up for milliamps DC. I'll power it up, and I'm getting obviously only a little bit of current. I can adjust these two variable resistors to an oscilloscope. You don't need an oscilloscope, but you can experiment with these two variable resistors to find a different frequency that matches your coils. In any case, if I move the transmitter closer to the receiver, clip's in the way. So I could probably light up an LED from about 2.5 centimeters away at this specific frequency. I'm using a low power mode, so I'm using a frequency that's not perfectly matched to these coils, because if I found one that was perfectly matched to it, I'd be able to draw a heck of a lot more current, but only for short amounts of time, or else I'd burn the traces. So again, see how fast the current up the closer I get to the receiver. It's pretty neat. Now if I put it right up to the receiver, I can actually get even more, but this clip's in the way. So let's say at this distance I've got about roughly 2 centimeters there, and my efficiency at that distance is not very good. My DC power supply is saying I'm sourcing 57 milliamps. So if I adjust, hopefully I don't get in the way here. I don't want to tinker too much with the frequency here, but pardon my fingers. I can adjust it to make the power go down or even up slightly from this distance. So this is how it's a customizable board. You don't have to use these. You can use your own coils, and I'll be selling these in kits, and down the road I'll be selling them as modules as well. So really good efficiency at certain frequencies. Depending on the frequency, you'll find really good efficiency or horrible efficiency. But that goes for any coil. And so yeah, this is basically just a concept. It's not an original concept, I don't believe, placing coils on a circuit board. I know that this is essentially just an antenna, but yeah. So hope you enjoyed the video. I'll be releasing these relatively soon once I've tinkered around a bit. I literally just got the PCBs in about an hour ago, so I've been soldering like a fiend. Thanks for watching, guys. I hope you enjoyed it. Have a great day.